Almost everyone has felt it. The doors slide shut, and a quiet, intrusive thought creeps in. What if the primary cable snaps right now and this box plunges to the basement? It is a perfectly rational fear. You are standing inside a metal cage, suspended hundreds of feet in the air by nothing but a few ropes. But a modern elevator free falling down a shaft is virtually impossible. Statistically, you are much safer riding inside that suspended box than taking the stairs right next to it. To understand why, we need to look at what actually holds you up. We are going to intentionally cut the cables on a fully loaded car and watch exactly how a century and a half of engineering reacts. The reason your worst fear is a phantom comes down to one obsessive design principle: redundancy. It relies on multiple, independent backups working together so that no single failure becomes a disaster. The first layer of defense is the suspension system itself. You aren't hanging by a single rope. A standard elevator hangs from a web of 4 to 8 independent steel cables. Just one of those individual cables is strong enough to hold the entire fully loaded car by itself. On the other side of the top pulley is the counterweight. This massive block of steel balances the weight of the elevator car plus a portion of its passenger load. This weight ensures the motor doesn't have to work as hard, but it also alters the physics of the entire system. Because the two sides offset each other, a simple, rapid downward plunge is not how the machine naturally behaves. For a free fall to even begin, an extraordinarily unlikely event has to occur. Every single one of those independent steel cables would need to suffer a catastrophic failure at the exact same time. So, what happens if every single cable is miraculously severed at once? In 1854, an engineer named Elisha Otis answered this directly. He stood on an elevated platform at a New York exhibition and ordered his assistant to sever the main support rope with an axe. Instead of falling, the platform dropped a few centimeters and violently locked into place. Otis had invented the safety brake. If the main cable goes slack, a spring-loaded mechanism shoots outward, gripping the guide rails on the sides of the shaft. That single public demonstration proved elevators were safe for human passengers, making the vertical expansion of modern cities possible. But what if the cables hold tight, the motor fails, and the car starts accelerating downward on its own? That scenario triggers the overspeed governor, a dedicated mechanical speed sensor independent of the main motor. As the descending car spins the governor wheel too fast, centrifugal force pushes flyweights outward until they mechanically lock. This yanks a linkage cable, forcefully tripping the safety brakes. Even if all those systems somehow failed, heavy-duty springs and hydraulic buffers sit at the very bottom of the pit as an absolute last resort to cushion the impact. This overlapping fortress of independent mechanical systems is exactly what engineered the terrifying plunge out of existence. Curious, if the machine is practically incapable of falling, why do elevator accidents happen at all? The data shows that the vast majority of elevator-related fatalities do not happen to riders. They happen to the mechanics and technicians working inside the dangerous, exposed environment of the shaft. For everyday passengers, the genuine hazards are surprisingly mundane. The actual risks involve getting caught in closing doors or tripping over a gap when the car stops slightly misaligned with the floor. These threshold hazards disproportionately affect vulnerable riders, children, and people using mobility aids or heavy luggage. Public anxiety is entirely misaligned with real-world data. We fear the vertical ride, but the actual danger is horizontal, right at the doors. There is one final passenger fear we have to address: getting stuck inside a car between floors. When an elevator stops unexpectedly, it is usually not broken. It is doing exactly what it was designed to do, safely holding the car securely in place because one of its redundant sensors detected an anomaly. The deadliest thing a passenger can do in this situation is panic. When trapped riders force the doors open and climb out through the gap, they expose themselves to the massive, deadly drop. The absolute safest action when stuck is to stay calm, stay inside the box, and wait for help. The modern elevator is a masterpiece of overlapping protection. The 19th century machinery keeping it suspended is nearly infallible, leaving human instinct as the system's only true flaw.